So the product I chose was a curling iron, and the prices I chose for my table were $20, $25, $30, $35, $40, $45, and $50 because I have seen curling irons range between these numbers. And then I surveyed 80 people to find out what they would pay for the curling iron. I then went and put my data in a table in Desmos and did this equation to find my linear model. So my linear model is going to be right here. The bluish purplish line right here shows the linear equation, and the green dots are the points. So as you can see, it's a pretty straight line. If you look over here and look at R, it's negative 0.9452. So we can conclude that the correlation coefficient is decent because it is close to 1. And then to find the revenue equation, I then went back into Desmos and typed in this right here, and then plugged those numbers into that. So the equation is going to be right here. I did not round to show the equation, but I do round as we continue on. So I know it's a little confusing, but number 7, so to find the vertex, you do negative b over 2a. So we plug these in, a, b, c, and we get 52.11. And then you're going to plug that into this equation in order to get the y value. So we plug that in and we get 1.92, so our vertex is 52.11, comma 1.92. We can then go into Desmos and click on the vertex point and see that it's pretty close to what we got. We did round numbers, so it might be a little different, but it's close. And then to find the break-even points, I just went in to Desmos and I see where the the linear equation intersects with the revenue equation, that quadratic equation. So one is going to be right here, and then the other is going to be right here. So number 8 says to decide on a reasonable cost to manufacture the item. So I just said, let's say it costs $5 to manufacture the curling iron. So we then take 5 and multiply it by the demand model, which was right here. And then to put it into the C equals mx plus b format. So this is what we get. And then in order to find the profit equation, profit is revenue minus cost. So we do, where is it? This equation minus this equation. So we put it all together and then we simplify it. So we get 0.023x squared plus 1.422x plus 255.324. We then do the vertex formula again, so negative b over 2a, and we get negative 30.913. So we plug that into the equation that we just did over here, and we get 233.345. So the vertex is going to be this right here. So then we can go into Desmos and see, like, compare what we got in here, and we actually got the same exact number for the vertex. And then because the it doesn't touch the x-axis, so there are no x points for this graph or this equation. So I chose a random number to plug in. So since 28 wasn't in our table, I chose to plug in 28. So if we make the curling iron $28 and we plug it into our profit equation, we would have a profit of $313.17. And then for number 12, for picking a profit that you would want to make, I just chose the number $400. So instead of plugging it into the equation, we plug it in at the end right here. And then we're going to subtract the right side of the equation and put it all on one side and let it equal 0. We're then going to go in and use the quadratic formula, and we get 54.209. So I would have to sell my product for about $54 to make a profit of $400. And for the extra credit, the reason why the price point for the maximum revenue and profit are different is because profit is revenue minus costs.